right, in today's lesson we'll be talking about what's a radian versus a degree on a unit circle. So first we need to understand how to draw angles. An angle in standard position is if its vertex is at the origin. So here we have an x and y axis. It's at the origin here. And its initial side coincides with the positive x-axis. So here's the initial side. We always start on the positive x-axis. And then the terminal side will end wherever the degree of the angle is. And it goes counterclockwise. We could have positives and we could have negative angles. So positive angles are going counterclockwise. Negative angles are going down clockwise direction. We're going to do a couple examples on that. But there's another definition that's important, something called coterminal angles. These are two angles that have the same initial side and terminal side. So taking a look at this one right here, the alpha angle, here is the initial, here is the terminal side, has the same as this beta angle, this B, same initial and terminal side. In this example over here on the right hand side, here alpha has an initial and a terminal side, and the beta angle also, if you take a look, has the same initial and it goes all the way around and meets up again with that terminal side there. Those are called coterminal angles. Alright, let's sketch some of these angles. So let's take a look and do these first three together. So whenever I'm going to sketch an angle, I always want my x and my y axis. I'm going to start with my initial side right here on that positive x-axis. I'm going to do 90 degrees, so we know it goes up. 90 degrees is right here on that positive y. So number one, this is a 90 degree angle. For number two, again, we're going to make our x and our y axis. We're going to have our initial side on the x. 45 degrees is going to be halfway in between, somewhere in there. That's going to be 45 degrees. Number three, I'm doing negative 60 degrees. So that's a negative angle. So a negative angle, again, still initial side is on the positive x-axis. It's going to be going clockwise direction this time. And here we go, down somewhere in between, a little bit more than 40, negative 45, so that's negative 60 degrees there. All right, you guys go ahead and do 4 through 8. Come back and take a look at the angles and see if you got them right. Okay, here is 270 degrees for number 4, 60 degrees, number 5, negative 90 degrees, number 6. Here is 225 degrees for number 7. And now number 8 is kind of strange, right? Because you're starting at your initial positive x-axis. You're going all the way around 360 degrees. And then another 90 degrees to get to 405 degrees. That's what it should look like with the curve of the arrow showing that you went past 360 degrees there. All right, moving on. Let's talk about that coterminal angles again. Remember, coterminal angles are angles that have the same initial and terminal side. So, for 30 degrees, let's first sketch 30 degrees. Here's the initial side. 30 degrees is somewhere less than 45, it's 30 degrees. Well, if I wanted to find a coterminal angle, I would still have that same initial side, but then I'm going to go around clockwise direction to get to that terminal side of the 30. So how many degrees from 360 and that 30 going to be subtracted? What is left? 330 degrees. And it's actually a negative angle because it's going clockwise. So the coterminal angle for 30 degrees is negative 330 degrees. All right, let's take a look at negative 45 degrees. Let's sketch that. So here's my initial side. Negative 45 is clockwise direction. This is negative 45 degrees. If I wanted to find an angle that's got that same initial side, but now it's going to go the other way around and meet up over there. Well, what is 360 minus the 45? That gives us positive 315 degrees. So the coterminal angle for negative 45 is 315 degrees. And then for the last one, it's 210 degrees. So here's my initial side. 210 is going past the 180. That's my terminal side there. This is 210. Well, I want to go the other way, so I'm going to still start with that initial side, and it's going to meet up with the terminal side there. So what is 360 minus 210? That's negative 150. All right. What is the relationship between a degree and a radian? So we know degrees use the degree symbol. Radians, if you remember from Algebra 2, use that pi symbol. And the reason why we get pi has to do with something called a central angle. So here's a picture of a central angle. If you remember from geometry, its vertex is at the center of the circle. The radius here is r. And if we wanted to find this length here, this S length, all three of these are going to have the same length, S and the R for the radius. So a radian is the angle inscribed by an arc whose length is equal to the radius. So that's why we have over here S equals R. A central angle of one revolution will be an arc equal to the circumference, right? So if I was to go around the whole circle there, that would be the circumference of the circle. So in the formula that represents how to find the length on a circle, that S equals R times theta, that's the formula to figure out arc length. If I was to take the whole circle circumference, and hopefully you remember what circumference is, 2 pi r, to equal that arc length, and then I go ahead now and solve this for theta. So I'm going to rewrite it over here, and I'm going to solve this for theta. So if I divide the r's over, they cancel out. So I get my theta to be 2 pi. What is 2 pi? Well, that is 360 degrees. So we know that 2 pi radians around the whole circle is represented as 360 degrees. I could go ahead and keep breaking this down. If I divide by 2 and half the 360, I get it to be 180 degrees, which is pi radians. And I could keep going and getting more. So let's take a look at some common things here. So here we have our quadrants, our 4 quadrants. Top right is quadrant 1. So it's going from 0 to 90 degrees. So 90 degrees is being represented as pi divided by 2. Because pi, right, from the other part that the other slide, pi was 180 degrees. Quadrant 3 down here in the bottom left goes from 180 to 3 pi over 2, which is 270 degrees. And then it goes around to the complete circle, 360. If you don't quite understand how they're getting the radian to the degree, that's okay. This is the most important thing right here. So to change from degrees to a radian, you're going to multiply it by pi over 180. And then I'm going to show you in the calculator, press math frac, and you'll see what happens to get your answer there. To change from a radian to a degree, that's easy enough. You just replace pi with 180 and you multiply it out. So let's take a look at a few examples here. Let's see. Okay. So up here, we are going to convert the following to radians. So the first one I'm going to do is negative 250 degrees. So to change from a degree to a radian, we're going to multiply it by pi over 180. Pi over 180. So you'll want pi left in your answer. So pi is just going to come over. And then if I do this in Desmos Online, take a look. I did negative 250 divided by 180. And here they actually reduce it right here and change it to the fraction. And it becomes negative 25 pi over 18. So the pi is going to stay in your answer for radians. So you're basically just dividing by 180 for the degree. If you're using the TI calculator, which is right here, you're going to go ahead and put it in your calculator. You get this decimal. Who remembers how to change a decimal to a fraction on the TI calculator? Well, you press that math button here, And these are the things that are going to show up. We want to change it to a fraction, and we go ahead and press enter, and then we will get our answer of negative 25, and then we put pi in there over 18. All right, let's try the next one here, 120 degrees. So if I do 120 divided by 180, pi is going to be on the top. Go ahead and try that in your calculator and press math frac to reduce it. We get it to be 2 pi over 3. Now, what if I wanted to go the other way? Convert the radian to a degree. Easy peasy for this one. So for pi over 3, it says all you do is you replace pi with 180 and multiply it out. So I'm going to replace that with 180 over 3. And what's 180 divided by 3? That is 60 degrees. And then for this one here, I'm going to go ahead and put in 180 for that one. Negative 2, times 180 is the pi, divided by 5. I multiply the top, divide by 5. I get it to be negative 72 degrees for this one here.